example, we're going to be graphing this function using transformations. We're going to start with whatever the parent function is and then track how each of the transformations change the graph. Now, the first thing I want to point out is that first, let's talk about how many transformations this function has and what the parent function of this function is. So starting off with identifying the parent function, all this means is which of the 8 functions from lesson 9 did this function come from? What's the parent for this function? So back in lesson 9, we looked at 8 different functions, and one of those functions was edited, altered, transformed to give us the new equation. And in our example here, we can see we have an absolute value, and so our parent function is the absolute value of x. So your parent function should always just be the basic untransformed function, some function that came from lesson 9. What the parent function is, let's talk about what the transformations are. There's 3 transformations that are happening in this equation. One of the transformations is this -4 right here that's on the inside of the absolute value. Another transformation is the 1/2 that's being multiplied on the outside of the absolute value, and another transformation is the negative. So notice how I'm counting the negative and the 1/2 as separate transformations. Now the first thing that I want to discuss is that we are going to list the transformations, but we are going to list them in order. And in fact, I don't have to move it. And I say that because let's say that I tell you you have transformations of going up 4 and then reflecting over the x-axis. Okay. So if I take the graph of the absolute value of x, which looks like this, and then I shift the graph up 4, which looks like that then, and then I reflect that graph over the x-axis, it's now going to look like this, where this point down here is now at 0, -4, because it pushed up to 0, 4, and then it flipped over the x-axis to go to 0, -4. But what if I said that first you should take the original graph of the absolute value of x and then reflect it over the x-axis first. So now it's upside down, and then push it up 4. Now it's up here at 0, 4. So this was first doing reflecting over the x-axis and then going up 4. It's a different graph. So the whole point of this is that the order that you do transformations in does matter. And how we identify the transformations in order is by following order of operations. So just imagining if I were to plug a number into this equation, if I were to plug a number in, the first thing that would affect the number after I plugged it in for x is that we would have to do the -4. So whatever the -4 is, that is our first transformation. The next thing that would affect, it could be the 1/2 or the negative. It doesn't matter what order we take those in. So I'll say that second, and then I'll say third. But it is absolutely critical that we have the -4 listed as the first transformation. And I'm actually going to erase this for now, and we'll just kind of go through them step by step. So I'm starting with the parent function. I'm going to sketch a graph of what the parent function looks like. For the absolute value of x, the parent function looks like this. And I'm going to label 3 points on this. I know this goes through the origin. I'll say we also have the point 3, 3, and then I'll also just choose the point -1, 1. Another way I could have done this is I could have just made a table, and I'll just use the same points I used on my table. This is just going into the absolute value of x. This is just for the original parent function, and I have that there. So this is what the directions mean when they say to make a table with make a table or a graph with labeled points for each transformation and to use at least 3 points. So now we're going to actually start going through the transformations. Let's look at what the first transformation is. The first transformation is whatever, I'm just going to put first t. The first transformation is whatever is that x -4 doing to the equation. And so to help identify that, we're going to look at this equation and we're going to look at this equation, and we're going to say what changed from that equation to that equation. Well, what changed is that we replaced x with x minus 4. That's the difference between those two equations. We replaced x with x minus 4. So now I'm going to go up to my table, and in the column that says how did the equation change, I'm looking for where did I replace x with x minus a number, and that's happening right here. So now I know that the transformation is that the graph is moving right 4 units. Okay, so what the transformation is it is right 4. If I were going to go through this example with graphs, my new graph would now be shifting right 4 and look like this. We're going to track where our points went on the new graph. And we know that to move right 4, we'll also make a new table based off those points. This table will now be for the absolute value of x minus 4. But we know that moving right 4, we need to be adding 4 to our x coordinates. So instead of the point -1, 1, we are now at the point 3, 1. Oops. We are now at the point 3, 1. Instead of being at 0, 0, we are now at 4, 0. I'm adding 4 to all my x coordinates. And instead of being at 3, 7, we are now at 4, 7. Wait, sorry, 7, 3. We're adding 4 to all of these x coordinates. All these points are moving right 4. So if we're doing this with only tables, I know that what I need to do to get to this table, to that table, is add 4 to x coordinates. So the y values, the y coordinates would not change, and they would still be 1, 0, and 3. But I'm going to take the x of -1 and add 4 to get 3. I'm going to take the 0 and add 4 to get 4, and I'll take the 3 and add 4 to get 7. And those are the same 3 points that we plotted on the graph. So now we're ready to move on and look at the second transformation. Let me move this over. The second transformation is what's giving us the equation y is equal to 1/2 times the absolute value of x minus 4. So now I'm looking from this equation to this equation, and I'm asking myself, how did that equation change? What's the difference between the pink equation and the blue equation? And the difference is that we multiplied by 1/2 outside of the function. We multiplied by 1/2 on the outside of the function. So now I'm going to go up to my table, and I'm going to look for where am I multiplying by a number on the outside of the function, by a number that is less than 1, whose absolute value is less than 1. And that's happening right here in number 6. Multiplied outside by a number whose absolute value is less than 1. So I know that we have a vertical compression, and we will get our new table by multiplying our y values by a. And in our case, a is 1/2. So what transformation is this? This is a vertical compression, or you could say that it's a vertical shrink. So if I'm seeing a vertical shrink, I should see the graph getting wider. So we'll talk about what the new graph looks like and the new tables. Because what we do know is that how the points changed, what we saw in the table for how the points change, is we're going to be multiplying our y values by a. And our a is a 1/2. So to get this new table, we are going to multiply y values by 1/2, or divide them by 2. So the x coordinates of 3, 4, and 7 will not change, but the y values will now be 1/2, 0, and 3/2. And to help us when we're plotting this, this is 0.5 and this is 1.5. And this equation should have the 1/2 in front. Okay, so now let's start plotting our points. Instead of the point 3, 1, we're now at 3, 1/2. 4, 0 is still at 4, 0, because 0 times 1/2 is still 0. But 7, 3 has now dropped down to be at 7, 1.5. So this graph now looks a lot wider because it was vertically compressed. So it was vertically pushed down, which is going to stretch that graph out to make it wider. And then we have one more transformation to apply. The third transformation is that minus sign that's out in front of that function. So we are looking at the equation y is equal to negative 1/2 absolute value of x minus 4, and we're asking ourselves what is the difference between that equation and this equation now that the negative has been factored in and we have multiplied the outside of the function by -1. So I go up to my table and I look for where am I multiplying outside of the function by -1, and that is happening right here. So I know that that is a reflection over the x-axis, and we will change the sign on our y-coordinates in order to get our new graph. So we're going to sketch a new graph that has now been reflected over the x-axis, and we're going to make a new table. And the new table is now for the entire equation because we've applied all the transformations at this point. So to get these new points to reflect over the x-axis, what we are doing is we are changing the sign on the y values. So now I'm going to, first I'll just draw what the graph looks like, I guess. And then I'll just label the points. So this is the point for 0 still. 7 1.5 has flipped over to 7 negative 1.5, and then 3 1/2 is now flipped over to 3 negative 1/2. As far as your graphs being drawn to scale, I'm not picky about that because you're going to be labeling points on your graph. So I'm going to know exactly what the points are, even if they don't look like what they're supposed to be, but they should look about right. So you can see that that graph has definitely been reflected over the x-axis, and from the points I know that it's wider than it was originally because it has been vertically compressed, and it also clearly did move right 4. So just finalizing this table, these y values in here, just changing the signs on those y values. So when you do a problem in class and you are graphing a function using transformations, you don't have to put all of this on your paper. You could choose to only go through the example and make tables, like just do this part over there. And then once you have the final table, you can use the final table to sketch the final graph, because it's this right here that's really our answer, that last graph. Or you could have chose to just gone through the whole example and only showed me the graphs and then end with that final graph.